Good morning everyone. How are you all? Today we are here to discuss a new important topic and very interesting topic. And what is that? So it is ocean currents. Now if we talk about the ocean currents, the questions come in our mind that what is ocean current? And the most important thing is that if we see or we are going to notice it according to the layman, what we used to say that oceans are still, means they do not move, but this is according to the common man or layman. If we see technically, there is a part of ocean water which is in motion and remain always in motion. The most important thing since million of years, and the main work of these ocean currents is to redistribute the temperature on whole earth. Now the question comes in our mind, what is ocean currents technically? So basically we can say that in simple term that a part of ocean water which is in motion, just like a river stream. Like if we talk about river current or we define river current, what we say that a particular source of water body or particular water body which is having a perfect source and moves in the influence of gravity from a upland or the higher land towards the lower part and finally merge into a water body or bigger water body, which have got many tributaries, distributaries and forms many landforms in its way along with the catchment area, all these things. A 3D means width, depth and length in a perfect speed. Like this only, a perfect part of ocean is in motion which is 3D in form, means a perfect width, length and depth, depth to some depth only. The whole ocean water is not moving in one direction, but rather only a column to some depth used to move, that is the surface ocean current. On the other hand, when you will study in more depth, there are subsurface ocean currents also or deep ocean currents also, which used to circulate and compensate the movement of the water which is being done on the surface. So we can say these are three-dimensional features of the oceans or ocean water having a perfect movement, unidirectional from the lower latitudes to the higher latitudes and from higher to lower latitudes, which helps in redistributing the temperature on earth. So in this way we define the ocean currents. Now the question comes in our mind that if these ocean currents are moving, so there must be some factors which are driving these ocean currents. Basically means the factors responsible for the movement of ocean currents, which is the most important thing. Now the question comes, why? So we know as geography is science and science always try to find the causes which are responsible for any other things which is happening. Like in our previous lectures, what we saw about the composition of gases, or you can say the greenhouse effect, structure of atmosphere, why the weather phenomena are taking place, or why we fly aeroplanes in stratosphere only. Then after the general circulation of atmosphere, the formation of pressure belts, wind belts, then after you can say the movement of wind belts and why they are known by different names like the roaring 40s, furious 50s, or how the jet streams are formed, Rossby waves, all these things. So everything has got a cause and effect relationship. Like this only, if we talk about the ocean currents, the factors which are responsible, for movement or origin of ocean currents. So according to the oceanographers, if we see, there are 5 possible factors which the oceanographers think that these are responsible for the movement of ocean currents or basically their generation. And what are those? They are temperature, means the temperature difference, then after salinity difference, Coriolis force, shape of coastline, prevailing wind, and the possible factor is ocean bottom relief, means ocean bottom topography. So these are the possible 6 factors which are you can say considered by the oceanographers for the responsible for the movement of ocean currents. In standard books, you will find only the top 5. This, okay. The ocean bottom relief, basically they are present on the ocean bottom. So some of the oceanographers think that they might be responsible, but every time they are responsible, it's not necessary, because these are the surface movements. So one by one we are going to see them, like the temperature anomaly or the you can say temperature difference on the earth. Latitudinally what we saw, that the whole earth is divided into different temperature belts: torrid zone, temperate zone and frigid zone. Now due to temperature difference, what happens, the ocean water which are present in the lower latitude, they get heat up due to the heavy insolation and more energy, which tends to move them towards the higher latitudes in the colder areas, because when they will be heated up, they will rise up and the ocean surface will become higher in comparison to those water which are colder in nature, because we know the cold water is heavier in nature, so they will sink down, and the warm water is lighter, so it will move up. So what happens, they used to create a slope gradient. Now when they will create a slope gradient, so the water will move from higher temperature towards the lower temperature to redistribute. Like that only, the colder water will move towards the higher temperature latitudes, means the lower latitudes, means the temperature difference is creating a slope gradient in the oceans over the earth, which are governing the movement, or you can say starting the movement of water. Now this temperature only used to govern the salinity of any place. Like we know that the warm water has more salinity in comparison to the colder water. Now the question comes, why? So when the water will be heated more, what will happen? The process of evaporation will take place, and when the water will evaporate, so the impurities will left behind, because we know salinity means impurities in the water, and it is measured in parts per thousand. So basically, if we say the warm water and the cold water, so cold water is having less salinity and warm water is having more salinity. That's why due to less salinity, the cold water or the polar areas are frozen, and the tropical areas or the equatorial areas water, due to high temperature and more salinity, they don't freeze down, because we know more the impurities, then the temperature anomaly will be there between the particles. Some are having the cooling point at some other temperature and other are having the cooling point on some other temperature. That's why the impure water takes longer time to freeze and the pure water takes shorter time to freeze, because of the heterogeneous and the homogeneous mixture of the water content. Now So as we are dealing with the salinity, let us see the salinity distribution of the temperature on earth. Sometime it is asked in exams that what would be the salinity distribution on earth. So if I ask you the maximum salinity, so you all will answer that the equatorial area between 10 degree north to 10 degree south will have more salinity, means as the water is going to be cooler, the salinity will decrease. But the answer is wrong. Basically, the maximum salinity of the oceans are found in the tropics. That is between 10 degree to 30 degree north and south latitudes. Now the question comes, why? Because equator is also having the maximum temperature. But if we talk about the salinity controlling factors, so salinity controlling factors and the evaporation controlling factors, equator and the tropics. First factor is the cloudiness, or basically the amount of insolation which is coming to the surface. Second thing, the amount of evaporation, and the third thing, that is the addition of pure water, which is rainfall. So if we talk about the equatorial area, we know the equatorial area receives more sunshine during the day, but in evening what happens? Thunderstorm take place, means cloud cover and addition of more pure water. But just opposite in the tropical region, only the evaporation take place. No such rainfall is taking, means evaporation is taking in both the areas, equatorial area also and the tropical area also. But equatorial area salinity is being compensated with the cloud cover along with the addition of pure water in the form of rainfall. But in the tropical region, only the evaporation is taking place. No such addition of water or pure water is taking place by the process of rainfall, or you can say precipitation. That's why the maximum salinity on earth is present or found in the tropical areas or the latitudes between 30 and 10 to 30. Then after, the equatorial areas have medium salinity, means lesser than the tropical region. Then after, as we will move from 30 degree towards the pole, the salinity of the oceans will decrease as the temperature will start decreasing towards the polar area, and the least salinity will be of the polar areas. So in this way the salinity difference is there. Now when the salinity difference will be there, the process of O and RO, osmosis and reverse osmosis, will take place, means the movement of water from higher concentration towards the lower concentration and from lower concentration towards the higher concentration. So we can say that the temperature is governing the salinity. So the movement of ocean water is being driven by temperature, then after the salinity. But despite of the difference in temperature and salinity, when the ocean water will move, the third factor which will, you can say, override the effects of temperature and salinity will be the shape of coastline. Now the question comes in your mind that how the shape of coastline is going to affect the movement of ocean currents. So let's have a look. See, this is our world map, as we can see, and this is equator. So due to temperature difference, some of the ocean currents are there which will move in the difference of pressure, okay, temperature difference and salinity difference. And when you will notice in the atlas or the ocean currents map, what you will find, north equatorial current is here also and north equatorial current is here also. And it is here, south equatorial here and here and here. Now, this current wants to circumnavigate the whole globe, basically, means it will move. So, when it will move and try to move from this part to this part, suddenly the continental mass is coming in between. Now, we know that the oceanic floor or the oceanic crust and the continental crust both are lying on asthenosphere, which is also known as magma chamber. So, it is not going to pass from the bottom, but rather the shape of the coastline will govern this movement. Like this, only the south equatorial current, which is moving in Atlantic, will take the coast of Brazil. The north equatorial in Pacific, when it will come, it will take the shape of Japan. The south one will take the shape of Eastern Australia. So, in this way, basically, the shape of coastline is diverting the movement of ocean currents. They want to move on whole globe in a circular manner, but due to presence or coming of continental plates in the way, they are forced to move according to the shape of the coastline. Means it is being superimposed on the temperature and the salinity effect. So, what we saw, that due to temperature and the salinity difference, if the ocean currents are moving or the part of the ocean is moving and wants to move on whole globe, the shape of the coastline are forcing them to move according to that. Now, the fourth one, that is the Coriolis force. And if you remember or recall the Coriolis force, what we know, that Coriolis force is applied on every freely moving object on earth, in which the freely moving object in northern hemisphere are deflected towards right of their path in northern hemisphere and towards left of their path in southern hemisphere. This means if we consider the ocean currents of northern hemisphere, the currents used to move like this is north equatorial. We will see the currents one after the another and basically of every ocean separately. But before that, suppose these two currents, number 2, number 3, Florida, Gulf Stream, they are coming out from Gulf of Mexico. And the most important thing, when they will move, they are freely moving, and when they will freely move, the Coriolis force will be applied because they are a particular part of the ocean, as we discussed earlier also, to some depth. They are not stick to the surface of the ocean bottom also. So, when they will move, the Coriolis force will be applied, and when the Coriolis force will apply, they will turn towards right of their path and again towards right and again towards right. So, as we will move down, basically it will make a churning gyre, and this is only considered as the Ekman spiral, which you will study in depth either in optional or when we will study the Ekman spiral to some depth. Basically this is of the optional part, so no need to study in the GS section. So, we will discuss it further in detail. So, this spiral is considered as the Ekman spiral, and basically it is making a gyre. Now, this section will move like this and take the shape of the canary current, as we know. Why? Due to the Coriolis force. Like this only, the other sections also, when they will move right. So, the Coriolis force is being applied in the open ocean, where the ocean currents are moving freely and form the oceanic gyres. Then after, the fifth one is the prevailing wind. Now the question comes, how the prevailing winds are affecting? The Gulf Stream, when it comes out, it comes under the influence of westerlies, and when it will come under the influence of westerly, it will become the North Atlantic drift. Like this only, the speed of westerlies are more pronounced and high speed in southern hemisphere. So what you will find, the west wind drift in the southern ocean. Mind it, the currents which are having the suffix of drift, North Atlantic drift, North Pacific drift, west wind drift, means they are under the influence of prevailing winds, means permanent winds, or you can say the planetary winds. And about these planetary winds or prevailing winds, we studied them in general circulation of atmosphere, that they are moving on earth in this direction only since million of years, which are helping in regulating the temperature on earth. So basically, when they will move, they will just drag the ocean water in their direction. So these are the 5 major factors which influences the movement of ocean currents, as we know, on the earth. And the 6th one, which was the ocean bottom relief. Now the question comes that how the ocean bottom relief is going to determine, or you can say affect, the movement of ocean currents. So basically what happens? We know that the oceans are having almost the same features which are present on the continental part, like the mountains also, plateaus also, depressions also, all these things. But they are named differently. Like the mountains present in oceans are considered as seamounts. The flat topped hills on the continental part are plateaus, but in the oceans they are considered as guyots. The depression on land are canyons, but those depressions formed in the ocean floor are considered as trenches. Then after, you can say the undersea volcanoes, and the plain area on continental are basically the alluvial plains, but that plain in the ocean bottom are considered as abyssal plains, means almost all the features the ocean bottom is having which is present on the continental part. So what it is believed by some of the oceanographers or the scholars, that this ocean bottom relief also somehow affects the movement of ocean currents. Like suppose if some current is moving and on the ocean bottom there are huge mountain ranges, or you can say they encounter the guyots. So basically when they are encountering some mountain range or a ridge, so what will happen? They will either get bifurcate or they will change their direction. So what they think, that the subsurface ocean currents might be affected by the ocean bottom relief, but it is not well understood and confirmed that are they affecting it or not. Mind it, because we are concerned about the surface ocean currents, and if we talk about the oceanography, we humans are only able to understand and explore nearly about 1 to 2% part of the Earth's ocean. Means maximum of the Earth ocean is unexplored still today also, and we don't know that what is exactly lying inside the oceans. So we are also not able to understand that apart from these factors, are there some other factors which are affecting the movement of ocean currents? There might be, but till today what we have figured out, that they might be the possible factors which are responsible for the movement of ocean currents. So these are the factors which are responsible. Now in the coming lecture, what we will see, that the movement of ocean water in every ocean has been named and given some, you can say, prefix, suffix or some characteristics, and every currents are having some important characteristics along with their peculiarity along the coast where they reach, or basically they affect the fishing industry along with the shipping industry also. Like previous year only, they have asked the factors which are responsible for the movement of ocean currents, discuss them and how they affect the fishing industry over the globe, or how they affect the shipping industry over the globe, positively also and negatively also. So we will discuss them one after the another in all the oceans which are present on earth. So we will meet in the next class with the different ocean currents of earth along with their characteristics and peculiarity. So thank you. Have a nice day.